Hey folks, welcome to another set of Chemistry 1 video notes. Today we'll be talking about physical and chemical properties and how we can use those to identify substances. We'll be covering the following standards: C.1.1, C.1.2, and C.1.7. So first, what are physical and chemical properties? Physical properties are properties that can be observed without changing the identity of the substance. At most, you might have to take the substance through a physical change in order to observe a physical property. Some examples of physical properties are density, volume, color, shape, size, malleability, which is can you hammer into thin sheets, ductility, can you stretch it into thin wires, boiling point, and melting point. Chemical properties, on the other hand, can only be observed if you change the identity of the substance. In other words, your substance must undergo a chemical change in order to observe a chemical property. Some chemical properties are pH, so is an acid or a base; toxicity, is it toxic to living organisms; radioactivity, does its nucleus release particles; reactivity, what other substances will it react with; and combustibility, will it catch fire. There are two types of physical properties. We have intensive and extensive. Intensive physical properties are constant for a substance regardless of the amount of substance you're measuring. For example, the color, temperature, density, conductivity, boiling and melting points, all of them will stay the same no matter what your sample size is. Extensive physical properties change depending on how much you have. For example, the mass, volume, energy, heat capacity, entropy, they'll all be different if you have a small amount versus a large amount of that substance. When comparing substances or trying to identify substances, it's important for us to look at those intensive physical properties. You've probably learned this before, but a pure substance only contains one type of matter, one element or one compound. It doesn't have more than one type of element or compound in it. That's why it's pure. A mixture has multiple substances mixed together. In order to determine if a substance is pure, you can look at its various chemical and physical properties. The easiest to look at are density, boiling point, and melting point. You can easily find the book value, or what scientists agree is the correct value, for those three properties, then compare them with the values that you found for your substance. If you still can't identify the substance at that point, you could try undergoing various chemical reactions in order to observe its chemical properties. However, it's likely that you probably have a mixture. A big difference between pure substances and mixtures is that the intensive physical properties and the chemical properties of pure substances always remain constant. Those properties can easily change in a mixture depending on what the mixture is made up of. So, short story, if you want to identify an unknown substance, take a bunch of measurements on it. Find its values for various physical and chemical properties, then go compare them to the various book values until you find a substance that matches. Since finding physical properties won't destroy your sample, I suggest finding the physical properties first, then move on to chemical properties if you need to. You've probably already had plenty of experience with density, but here's a short refresher. Density is one of our intensive physical properties. That means that any size sample of a substance will have the same density. To find the density, you got to measure the mass, measure the volume, then take the mass divided by the volume. To find density of a solid, you just have to measure the mass and volume. For a regular shape, you could use a ruler and a little bit of geometry to find the volume. Or for irregular shapes, you could use the displacement of water in a graduated cylinder. To find the density of a liquid, we could create a density column with that liquid and various other liquids that you know the density of. Then you've got a pretty good guess about where the density is for your unknown liquid. You can also add objects to this density column as long as you know the density of those objects, and then see where they land on which layer, and that might give you a good hint at which layers are which densities. It might, however, be easier to just find the mass of your liquid inside of a graduated cylinder and subtract the mass of the graduated cylinder from that, so you know just the mass of your liquid. Then, since the density of gases are easily changeable, as you've seen, it's not useful to find their densities. For most substances, the solid form of the substance is the most dense, with liquid coming in second, and then gas is the least dense. This is not the case for water. As you know, ice is less dense than liquid water. That's why it floats on top. Well, that's all we have for today, folks. As always, if you have any questions, please let me know.